Assalamu alaikum. Hi everyone. This is a revision of our last lecture in which we studied about tangent line. The concept of tangent line is concept of our tangent line is you can say that the advanced version of a slope, where in slope we are observing the total change, or you can say average change, but in tangent slope of a tangent line we are observing the information at an instant. In a precise way we can say that in short interval the change we observe is noted as a tangent slope of a tangent line. Let's see that this is a function. I already explained it in the last lecture. So the graph of, while we are observing the value, random value of x in this function, where x should not be equivalent to 0, in this situation we will get a graph of this function like this way. For the both the edges we will notice that once the function is away far away from the origin or the central position 0 on a real line, it will give some kind of dumped oscillation. You can say that the signal is reaching in a minimum frequency. Very simple example of this is that if I am talking from this point, maybe a person who is sitting near to me will listen me that I am at center. Okay, the person who is sitting near to me, the maximum, though it is not exactly maximum, which is just the signal which is leaving my mouth, so it is not kind of exact information, but the person who is sitting near to me will hear me clearly. But the person those who are sitting though on a positive side or the left side or a right side, concept of a left hand side limit, right hand side limit, both goes in a same fashion, that this function, usually once we apply that limit delta x, or you can say that x distance, distance approaches toward 0, in this situation f of x, so it will becomes what? F dash of x, that is representing tangent slope of a tangent line, or you can say like this. So, and the value of this sin x we are substituting here in this situation. Once we are applying limit on this right hand side, we will see that x approaches to 0. This sine of x, our x, is giving an answer equivalent to 1. 1, not exactly 1, though it is also kind of an approximation. So similar, it is also kind of the signal variation. For example, if we are sitting very far away from some light, that near the light brightness is too high, but as we are proceeding far from the light, then of course the effect of a light will be diminished or maybe minimum like this. Dampening is occurred in a signal and it will gradually be decreased. So let's see the mathematical concept of the tangent line. Like, find the tangent line. In this situation, in a very simple form, we need to see some function, tangent, because once I am not speaking anything, no signal will be occurred. For observing some signal information, of course I need to speak out. So there should be some activity, and this activity is known as a function. And we can say that if I am speaking too loud, then this y, height of my pitch, okay, it is going too high. If I am speaking very slowly, then of course this graph is too low. This is the y is kind of a range of my speaking, my voice in terms of loudness. So x is my voice will cover some distance. Definitely, okay, it's very simple, okay, so along the curve or some, okay, straight path, it doesn't matter, but it also can be observed on the mobile towers, similarly on the line, but it's the advanced version. But the basic thing is this, that find the tangent line, and the concept of this tangent line, there should be some fixed point, and this fixed point, it can be representing with some origin, that is the x naught, y naught, that is the fixed point, origin, point of origin from where the source will be generated. So once we are talking about the point of origin, the simple change about that point can be represented with simple equation of slope, the slope of a normal line, and it can be noticed with this. We already studied it. So in this equation, we know that y naught, it is our origin, point, our function at origin, and once there is a change in this function, this origin, if I, as I am already told you people, if I am speaking, okay, silently, there is no function, there is no voice, so function is just dull. But once I am speaking, for example, from silent, I am speaking, so what happened? The change in voice is happening. So this change is representing with f dash. That is the derivative. And my frequency of voice at an instant is determined with this change. That derivative is telling this slope of tangent line vertical, okay? For example, this is a signal, and as we are usually talking, that this is a curve, and this curve, this, okay, vertical, that, or you can say that this line touches the curve only and only at one point, that my voice intensity at single point observation, at single point, is known as the information at an instant, or we can say that derivative change is happening. Derivative is telling what? Derivative, we can say that df or dx. This is like this thing, and this is original, and we can say this is the stuff, the change, small change. If we are writing like this, then it is representing the average change, big change. So once we are talking our overall voice intensity, but if I am talking about a particular instant, then it is representing with the derivative. This is slope of tangent line. That is the slope of normal line. So with this slope, we can see a little bit further the mathematical expression of the slope. Before proceeding to the next, I would like to define this. The definition of tangent line. For your memory, I am writing it here, that slope of tangent line at fixed point x naught is known as the derivative of some function. Function means kind of any signal, audio signal. Function at fixed point from source of origin is the slope is known as slope of the tangent line. Very simple. This definition should be memorized, and this slope of the tangent line to some function y, unknown function. Okay, signal is unknown, or you can say that long generated signal. This one. That this derivative is the some part of some significant small slightest part of information of this long, or you can say that the complete or big signal. This is definition of slope of the tangent line. So okay, the geometrical interpretation of this slope of the tangent line can be shown in a graph. For example, we have some point here, and this point is definitely, I am talking that a line passing through the curve and touches only the one point, and this is the one point. We make the color of a line a little bit different. So this is the line, and it touches the curve only at one point, and this point is representing some P, and of course the fixed point location is x naught, and along vertical axis it is y naught. So we can say this P can be representing a point x naught, y naught. However, suppose there are random signals. For example, in a one room, there are too many people are talking. Okay, of course, there is kind of a noise, audio noise, and suppose there is some another, okay, and this is a noise, and so another red line is showing some kind of another point of, you can say, discussion in a room. So, but it may be possible at some point all of fellows in one room, okay, for example, this P and Q, two different persons who are talking, but at some point our discussion, they are uttering the same words. Same words. For example, they are talking about Pakistan, but at some point they are saying Pakistan. What happened? So they will, this line, this Q will, this mean also touches only the one point. So the change from this initial point, that Q shift from the point of this region to this will cover some distance, and this distance along x-axis is representing with delta x, and similarly in this situation we say the change along y-axis height, okay, the change in some height, of course at this point you can say that it will be representing initially it was y naught x naught, but after shifting of this Q it will become f x naught plus delta x, that total change, okay, along vertical axis. So we can make it more simple. That this is a line. Here we can say that 2 points P and Q, and this P and Q, the horizontal change can be represented with delta x, and vertical change can be represented with delta f. So we can say that Q approaches to this. In all this scenario, one thing should be remembered, that Q approaches to P, okay, at some certain point where P is a fixed. P is a fixed one. So we simply memorize the basic equation of slope, that is the final minus initial. This one, it can, okay, as we know, y can be represented as a function of x, so we can write here that f2 minus f1 instead of the y2 minus y1, and same as it is. And this net change can be along f kind of function. This can be representing like this. So this is telling what? This all scenario is telling slope of the line PQ. Slope of PQ, that is line. Okay, rise or run. Okay, we already studied this in our previous lectures. So, but the important thing which is happening here is Q is approaching towards P. So the distance between x2 and x2 and x1, this is the x1, is almost, we are bringing both together, so almost negligible distance, or you can say that there is bit along horizontal axis. For example, both persons are approaching at the same point of discussion, that the Pakistan. So on the same world, once they are approaching, so definitely frequency will be matched. So maybe the then at that instance slope net change will be can be considered. Someone noticed that both are at same point. At what word? That the word is Pakistan. So at this moment, once they are uttering Pakistan, their total slope, or you can say that this average change becomes instantaneous change, and this instantaneous change is known as can be representing f dash, or you can say that limit is applying here. Limit is applying to this value delta f over delta x, as delta x approaches to 0, and this will become df over dx. This df over dx representing the very small, slightest possible change, that is df over dx. So we can, let me generate one more slide for example. So we can say that this change that happened is to tell us once we say delta, this limit delta x approaches to 0, it will become small sampling interval function, that is telling us a derivative, or you can see the slope of a tangent line. So we can proceed it further, but before proceeding further, I would like to say that this different notions is used for representing the derivative slope of tangent line, and similar I will explain. This one is representing by Newton's, introduced by Newton's, and this one introduced by Leibniz. These are two mathematicians or scientists. Okay, let's see one more example here. to illustrate this concept a little bit in more detail. We generated more slide for a few people. So, for example, we have some function, and the nature of function is f of x equal to 1 over x. This we need to take determine the slope of tangent line to this function, as this is function of y, some kind of a signal, and the nature of this signal is kind of inverse. And if we draw this signal in a 2D domain, we will see that graph is going like this. If you can substitute random value, okay, for example, x, negative x, positive x, so some random value, for example, negative 3, negative 2, negative 1, 0, or you can say 3, 2, 1, you will get this kind of a graph. Remember, whenever there is a 0, this graph is showing some kind of very poor performance. At the 0, this point is a 0, but this graph is not touching to the origin, okay, or you can say that leaving it and this want to get rid of the origin. So the nature of this graph is following the slope of tangent line. How? Let me explain it in detail. For example, in formulae, we know the basic formulae of slope of tangent line, rise over run. If we are writing it like this, and then our function becomes delta x, that is the y2, f of x naught plus delta x, and here the original function f of x, that is y1, or you can say y naught, y2 minus y1, kind of a rise, and our run is simply delta x. In next step, we can consider common denominator, and this common denominator can be representing like this, and we will have x naught minus x naught plus delta x, and in the denominator we will have x naught plus delta x, as well we have x naught. So here see, this x naught, negative x naught will be cancelled out with this positive x naught, and in remaining we will get delta x. This delta x will be cancelled out. Nominator of delta x will be cancelled out with the denominator of delta x. This term will be we get in a next part, that is delta f over delta x. We will have some kind of stuff where x naught plus delta x multiple of x naught. This is slope of normal line. Let's apply limit. Okay, we want to notice the change at an instant. Of course, we will apply that the range difference between delta x, that is x1 minus x2. It should be very small, or you can say that x1 is very near to x2, or delta x approaches to 0. Okay, the difference between x1 and x2 is minimum, so approaching to 0. So we will apply limit. It touches only the one point of a curve. Therefore, we say delta x approaches to 0 on our left hand side. Similarly, on our right hand side, limit delta x approaches to 0, and we will have this. Okay, let me erase this one. We will multiply this x naught, it will become square, x naught square plus x naught delta x. On applying the limit, our left hand side will become what? This will become the smallest change at an instant. So this dx representing very small interval of along on x-axis. So after employing the limit on this average change will give us the instantaneous change, and on our right hand side this whole term approaching to 0, so negligible term will become 0, and what we will have? We will have x square. So one thing, I missed it here somewhere. So in this part, see, once we will have cancelled out delta x with delta x, and this negative one, because one there is, of course, I did not mention it, but there is a negative sign. It will go here, negative sign, and of course we will have negative sign here. So this is output of this function, and we will have, due to this function, we can see that once we are from some space, from Russia or from America, from somewhere, satellite is boosting from Earth to the space. After some time, this is adopting this because satellite, what we want that satellite should not stay inside of the atmosphere. It should get rid of the Earth's nearest atmosphere. So we need to follow this kind